Welcome to the Zentrum Industrie 4.0 Potsdam. You are here in a unique research and transfer facility that has been created in recent years with funding from the federal German government and private third parties. The building was constructed by the University of Potsdam. The following minutes I would like to explain three things to you. What is the fourth industrial revolution really? What distinguishes the Zentrum Industrie 4.0 Potsdam from other learning facilities? What is actually happening here? Let's start with the first industrial revolution. It was triggered by the steam engine. Invented at the beginning of the 18th century, the steam engine was significantly improved by James Watt. From 1780, it began to replace human and animal labor with steam. The revolutionary thing is that much more power was available than ever before. Larger machines can be driven longer without fatigue. The second industrial revolution was organizational in nature. Frederick Taylor and Henry Ford completely rearranged the tasks surrounding the manufacturing of a product. By dividing the assembly of a car, for instance, into very many small steps, semi-skilled workers can now be useful. The work is done in cycles. In this way, a product is finished much more quickly. The revolutionary thing about this is that it becomes much cheaper to manufacture something, and many more people can afford these products. The third industrial revolution began with the use of computers in businesses starting in the mid-1960s. The 1960s saw the beginning of the triumph of the computer in manufacturing. It brought much more computing power than the earlier manual processing. This made it possible to plan many more variants at the same time. Products could be differentiated without costing more. Supply chains could be better monitored. Planning of quantities, schedules and capacities in the factory became possible. By the way, the IBM 360 in 1964 had a full 8 MB of memory, as much as a cell phone picture today. Almost 60 years ago, that was an incredible amount. At that time, computers were still very rare and very expensive. That changed in the years that followed, until personal computers were on everybody's desk. The fourth industrial revolution consists of two newer building blocks. Suddenly it was possible to pack high-performance computers into every object in the factory. Instead of simple commands, now complex operations were possible, up to and including artificial intelligence in the machine. Added to this was the networking of all these units in the factory with the internet. As a result, all these units are in principle always accessible from anywhere and can also exchange information with each other. Together, these two developments make up the basic building blocks of the fourth industrial revolution. Here comes an example.
In a traditional factory, each machine works off its supply of material on its own. When this is exhausted, the machine cannot continue working and goes into a waiting state. Only when a worker sees that material is missing, he can organize it in the warehouse. This waiting time is unproductive because the machine cannot work. Once the replenishment has been delivered, the machine can be productive again. In the Industry 4.0 factory, the objects in manufacturing themselves communicate with each other. The machine independently requests its supplies from the warehouse. The warehouse quickly sends material so that the machine can continue working. As a result, there are fewer unproductive waiting times.
So what is special about this Industry 4.0 center? First, let's consider what is necessary to set up a factory. You need a building, you need real and industrial IT, and you need something that tells you that you are in a factory. In our case, that's robots and conveyor belts like this one below me. What's missing then? Right, something has to be manufactured in the factory. This is where our first invention comes into play, our Industry 4.0 workpiece carrier. Our machines are built on the same principle, except that they don't move. They also contain cyber-physical systems and can communicate with all other objects in the factory. Instead, we have moving conveyors and robots that can also communicate with all the other objects in the factory. How do we demonstrate Industry 4.0? Workpiece carriers, our machines, and also the conveyor belts and robots are characterized by 4 principles. Workpiece carriers and machines visualize what is happening on them. All objects in the factory communicate directly with each other and exchange information. They have a variety of sensors to perceive information from their environment. Finally, people can interact with the objects in the factory in a variety of ways. To make all this possible, we need hardware and software that we have developed ourselves here in Potsdam. As hardware, we developed an Industry 4.0 box that can be used to upgrade conventional devices to cyber-physical systems. The FabOS operating system ensures that our virtual production runs smoothly, including real-time control of all connected logistical elements and robots. The special thing here is that we can map very many conceivable processes and interactions with completely different machines and tools, but also with vehicles and factories. That is what makes this Industry 4.0 center unique. Finally, I will show you some application examples for using the center Industry 4.0 Potsdam. Because we can map any processes between people and intelligent objects here, this facility is used very intensively for experiments. Psychologists, for example, are studying here how forgetting can be influenced. Sociologists are observing people interacting with very intelligent machines, and economists are researching how the desire for further education can be improved by financial incentives. Because we have a real and functioning factory, suppliers can test their new products here under realistic conditions. The Center Industry 4.0 also conducts comparative tests under real factory conditions. For example, we tested which VR glasses perform best in tough everyday factory conditions. The results of these comparative tests are published in the trade journal Factory Innovation. The concept of the Potsdam Center Industry 4.0 has also convinced other research institutions. For 3 years now, the university in Bochum, Germany, has been home to a laboratory planned and equipped by us, in which psychology conducts experiments. You also can use our lab. The topic of education and training is especially close to our hearts. That's why we regularly hold events for school classes, teachers, but also worker councils, so that everyone can gain an objective picture of what the manufacturing of the future will look like and what role humans will play in it. So now you know what Industry 4.0 is. what distinguishes our learning factory and what we can do here.